Section 7.2 is about substitution method, solving systems of equations using substitution method. And so we're going to write our steps down straight on our Cornell note sheet here. Substitution method. Number one, well, first of all, substitution method is what I call the lonely variable method. So we're going to write the steps down and then I'll go over what they mean to you. So number one, you want to solve for the lonely variable. Okay. Number two, plug that expression into the other equation. Okay. Number three, plug in the answer into one of the equations and solve. And then the final thing, write your solution as a point. Write the solution as a point, as an xy. Okay? So these are your 4 steps. Now let's use those 4 steps as we work through these examples. First thing I want to talk about is the 3 different types of systems. And there are 3 ways that these equations could materialize if you were to graph them. Now actually what we'll do is we'll do a couple examples and then I'll come back to those 3 types of solutions. So let's talk about example number 1. We've got the 2 equations, y equals 3x and x plus 2y equals negative 21. One of the ways that you can do this is with a little table. Again, this seems to help some people because it gives them some organization. So what we do above the line in the table here is if we don't have a lonely variable, we solve for that lonely variable. When I say a lonely variable, I mean we need to get either an x or a y totally alone. And right here, this y is totally alone. So this is our solving for a lonely variable. The first step is done for us already. Now if we look at our Cornell sheet, it says plug that expression, this one, into the other equation. So if we know y is equal to 3x, that means anywhere I see a y, I could put 3x in place of it. So that's what we're going to do on the left side here. X plus 2 times, instead of y, we put 3x equals negative 21. What does that do for us? You can see now we only have one variable, which is x, and we can solve for that one variable. So we'll simplify this and finish solving for x on the left side of this chart. So we get x plus 2 times 3x, which is 6x, equals negative 21. X plus 6x is 7x. And when we divide both sides by 7, we get x equals negative 3. We are not done though. Remember, we're looking for a point, a solution, which is a coordinate point. We need an x and a y. This is our x value, so here's our negative 3. But we also need a y value. So step 3 says plug in the answer into one of the equations and solve to get the other variable. Now it doesn't matter which equation you use, but I like to use the easiest one. I would say that this one's probably the easier of the 2 equations. So y equals 3 times our x value, which is negative 3. So y equals 3 times negative 3, which is negative 9. And here's the answer, or the solution to our system of equations, negative 3, negative 9. Okay. Let's try that one more time, then we'll talk about our 3 scenarios. So example number 2, x plus 5y equals negative 3, and 3x minus 2y equals 8. Let's go ahead and use our table. At the end, we're looking for a point. So we want to solve for the lonely variable. You can solve for the x or the y in the first equation or the x or the y in the second equation. Which one looks the most lonely is the key. Each of these variables all have a number attached to it, which means if we were to solve for this variable, we'd have to divide things by 5 and we'd get some fractions. Same with either of these. If we were to solve for this x, we'd have to divide everything by 3 to get rid of this 3, which will give us some fractions. And that is why we always look for the lonely variable, because it makes things a little easier for us. So that x is almost alone. He's relatively alone, let's say. But we need to move this 5y away. So when you have a variable that doesn't have a number, a coefficient in front of it, that's going to be the variable we're going to solve for. Sometimes you have more than one option. In this case, we only have one option. So we identified that this guy's kind of alone. We finished getting him totally alone by moving this 5y over by subtracting 5y. So we get x equals negative 5y minus 3. So that's your first step. Solve for the lonely variable. We didn't have to do that in the previous problem, but we have to do it here. Now, we take this expression that x is equal to, and we plug it into the other equation for x. Since that's equal to x, we plug it in for x. So we get 3 times negative 5y minus 3 minus 2y equals 8. Just take that whole expression and put it in place of x. Everything else stays exactly the same. Now we have only y's here, and we can solve for y now. Distribute here so we get negative 15y minus 9 minus 2y equals 8. Combine like terms. Negative 15y minus 2y is negative 17y minus 9 equals 8. Finish solving for y by moving this 9 to the other side. Negative 17y equals 17. Completely get y alone by dividing by negative 17. And we get y equals negative 1. Now that is only half the answer. That's our y value, which is negative 1. Put that in here for your y. We need to find our x still. So on the right side of the table, we're finding the other. Notice in the previous problem we found x first, and then on the right side we found y. Here we're finding y first. It just depends on the equation. Okay? So when we look at these two equations, which one seems to be the easiest? Well, this one, since that x is lonely, might make this a little easier. So I'll probably choose that one. X plus 5 times y, which is negative 1, equals negative 3. Finish simplifying this. X minus 5 equals negative 3. And then finish by adding 5 to both sides. X equals 2. So we get the coordinate 2, negative 1 to be the solution to our system. Okay. I want you to try number 3 on your own. 2x plus y, we'll do it together, equals 5. And 3x minus 2y equals 11. We'll do this one together. All right, so make your table. At the end, we should find a point. Okay. We're looking for a lonely variable. Which of those variables looks the most lonely? This y right here. So over to the right, we will solve for y. And what will we have to do to get y alone? We'll have to subtract this 2x. So when we subtract 2x from both sides, we get negative 2x plus 5. Now, take this expression. Since we know it's equal to y, we can plug it in place of y in the other equation. 3x minus 2 times this whole expression, negative 2x plus 5, equals 11. Finish solving for x. And go ahead and plug that back in to find y. I want you to try to finish this one all by yourself. So push pause here and see if you can finish this problem on your own. All right, so we'll have to distribute this -2. The 3x will stay the same for now. So -2 times -2x will give us +4x. -2 times +5 will give us -10 equals 11. We can combine like terms on the left side, 7x, and if you want, you can even move the 10 over in the same step. So if we add 10 to both sides, we get 7x equals 11 plus 10, which is 21. And divide by 7, we get x equals 3. That's your x value. That goes here on the left side of the coordinate point. Now choose one of the equations, the easier equation, which will, again, probably be the equation we solve for the lonely variable because this one's alone. So we get 2 times the x value, which is 3, plus y equals 5. 2 times 3 is 6 plus y equals 5. We need to get y alone, so we subtract 6 from both sides. We get y equals -1. So our y value is -1. Yay! What I'm going to have you do actually is do number 4 and number 5 on your own and bring them to class tomorrow. So number 4 is 2x plus 2y equals 3. And x minus 4y equals -1. So you can make your table and figure out what this coordinate point will be. I'll give you one hint. One of these will be a fraction, an easy fraction. Okay, so if you come out with an easy fraction for one, either the x coordinate or the y coordinate, you're on the right track. They won't both come out to be fractions. And then number 5 I'll tell you is a little strange. You will notice something weird about number 5. So we can talk about that tomorrow when you come to class and figure out what that means. But the first equation is 6x minus 2y equals -4. And the second equation is y minus 3x equals 2. So try example 4 and example 5 on your own. Bring them back to class tomorrow, and we'll discuss them at the beginning of class.